Hi everyone, my name is Roger Abakan. I am an industrial designer. If you like to design things, you like to 3D print, this is the right place to be. If you feel like you are learning something from my channel, please do not hesitate to subscribe, to like and comment. So I have a vacuum cleaner that I use. I bought it a few months ago and it's Shark Navigator. I have a part that is broken on that vacuum cleaner and I need to replace that part. I can't find that on the market. So what I'm going to do is to design the part that I need, 3D print it and replace it. As simple as that. I'll show you in more detail what the part is and give you some idea how I'm going to proceed to design it and 3D print it. If you want to see the whole process, stick around and stay tuned. This is the vacuum cleaner, the Shark Navigator. Vacuum cleaner that I like pretty much. I like a lot. And I'll show you the part that is broken. Let's pull out this part. Very easy to detach, and there are so many pieces that you can detach and clean separately, and that's something that I like. So what I did before was to tape that. I just put a tape on of a part that is broke, and I was using it that way. But I decided to create the design of a part myself and replace it. That way I can use my cleaner, my vacuum cleaner, on an easier way, and yeah, it's more professional. So this is what is happening. I hope you guys can see. This piece here is like a screw, and it latches inside actually. So you twist it and then it locks inside. But the part that locks inside is broken. So what I'm going to do is I'll just rebuild this and 3D print it so that it can lock properly. Instead of having a plastic tape covering that and holding them together, I'm just gonna rebuild the part. So here we are going to create the part that is broken from the vacuum cleaner, my Shark Navigator, and this is the part that is broken. I was able to remove it, and we are going to rebuild it. So first of all, I have my digital caliper here. It's going to help me to take accurate measurement. You don't necessarily need to use this guide, but I think it's just gonna make it quicker for me. So this is to suppose that this is the biggest surface of the part that is working. Let's measure that. Make sure that it's on 0. Take the accurate measurement, and it's 20 millimeters. So that tells me that this section right here is 20 millimeters. There's a screw at the bottom. We will do the bottom later. I want to focus on the top side first. We will do the bottom later. For a medium surface area here, let's measure that and see what is the size. Maybe a little bigger. So this is the medium surface here. Let's figure out what is the size. 0, measure that. 10 millimeters. So we write down 10 millimeters. And now let's measure the smallest surface area. It's about 650, 687, but let's put 680 or 670, 675. 675 for this surface here. 675 millimeter. Okay. For what is inside, I don't have a hole inside. I don't think it's very necessary, so I'm just gonna skip it. What I need to know though here, so I think these two teeth are what allows the part to lock when you close it. Let's represent them. And figure out what is the size of it. Zero, make sure it's always on 0. So I'll put 275, and for the length is I'll put 240. So it's something that is gonna be hard to represent here, so I'm just gonna put it on side. And 275, 2.4 millimeter, and that is for this. That is for the teeth. There's 2 of them. I think at this point that's mostly what we need. I'm thinking about this edge here. Is it really necessary? Oh, it is, because I think that is what locks from there. It is here. It is inside here, so that's what locks. When you move it, when you move this part here, it can fit and stay stable. So we're going to build that as well. Okay, it's gonna be a little bit tricky, but let's see how we can do it.